All right. Welcome to the SCIL session. This is. Oh, we locked somebody out. Welcome. Yeah. You want water also? Yeah. Okay.
You're doing good.
Good. Then, this is an introduction to SCIL. SCIL is SuperOffice client interface language. We like these short things, and I think SCIL is very describing for what this is. My name is Myhre. I'm a developer. I had a really good day when the picture was taken. It was in Vilnius, by the way, taken by the guy that sits down there. It was early in the morning after a late night at Vilnius. So, still coming people. The agenda for this session is I'm going to explain to you what SCIL is and how it works, and I'm going to talk about all the parts of what SCIL is, because there's a lot of parts there that does different things, and together they make a very nice client framework, framework for making web clients. So what's the purpose of SCIL anyway? The purpose of SCIL is that it should allow developers to create web application that you can use data that can change and reload the page without reloading the page, also known as a SPA. We had focus on speed, simplicity and scalability. The simplicity part could be debatable, but we think it's quite easy to use. It's only used for the user interface of an application, so it lives in the browser and it has nothing on the server at all. So it runs and lives in the browser. It's what we call recipe-based. It will take a recipe and it will turn it into something useful in the browser. I will explain more of that later. And it should be quite extensible. You should be able to extend it, add your own stuff. That should be easy. We currently are in the process of splitting up SCIL. Like we just made it and then we need to split it up. This is because we want to be able, for you to be able to use SCIL outside our clients. So the goal now is to split it up in 3 parts, 3 flavors. The SCIL core, which is the core of the SCIL framework, which has no dependencies on SuperOffice backend whatsoever, and it has only a limited, small set of components and controllers. All these controllers and components, I will explain what that is later, but you should remember this now, that it has core has a simple set, core set of components and controllers. The SCIL SO is almost like the core, just it has the look and feel of SuperOffice. So basically the components, the UI components, are skinned in a SuperOffice feel and look, and has a little more richer more components available and can be used for you. It's the purpose of this is for you to be able to make your own applications look like SuperOffice, and then maybe host them in a web panel in SuperOffice, but host it on your own running, or on your own servers, but it looks like SuperOffice. And then you have the full-blown package, which is SCIL, which is the one we use when we make UI for the clients. And that also requires some communication with the SuperOffice backend to enable to work. So, why do we have SCIL? That's because we want to move some of the load, CPU load, from the server to the client. The UI is entirely made in the browser. It's not on a servers at all. It's a static file on the server, basically, and that removes some load from the server. It also then gives us a much more responsive user experience with no need to constantly talk to the server to render or update the page. It's also very cloud friendly, because this is something that online will have use for, because it will, in online environment, we don't have that much power in the back in service for each client. So by putting more load into each own browser, it will be more cloud friendly. It's written in TypeScript, transpiled to JavaScript, and it should be easy to integrate and customize. So another bonus by doing it like this is that we now share this technology between sales and service. Another client, like front-end things we're gonna make, like forms and stuff like that, subscriptions. So it would be based on SCIL, and that means we can share UI between sales and service, and making it closer and making it look like one client, which it is not, but it will look like one. And we are, of course, not rewriting the whole every client to use SCIL in one go. So we are progressively implementing mainly new features in SCIL, and they live very fine side by side with the old page builder framework and the service framework. So for our developers in-house, the other goals were that we needed cleaner client code. We are coming from a world where you have JavaScript code kind of spread all over the place with no kind of compile time error detection at all. Untyped, not ideal working environment. We are now using TypeScript, so we get more typed code, and we have more compile time error detection when we build our application. We try to use unit tests on all components. You could call it a work in progress, but we are at least testing many of our components every build. And another goal was to make it easy for partners to make their own components, controllers and stuff, and add it to the SCIL library when they're making their own stuff. Also, the need for releasing the server, basically, from holding any state is an important goal, that we remove or move the caching and the state of the state on the server up into the browser. So then the cache is closer to the user, and it less load on the server, which is a good thing. So what we have used for developing this is TypeScript, what is that symbol? Webpack. I personally use VS Code. We don't need to use, we can use Visual Studio, it's fine, but VS Code I find is much more lightweight and much easier to work with. And we of course use a lot of helping packages from Node. We just there's so many modules there that they change, and we change, and we change, and we have 10,000 versions of each module. But we kind of settled on these 4 things here. Okay, so SCIL in sales and service today, they work very nice side by side with the old page builder and the custom screens in CS. Today we have implemented the new inbox in SCIL. We have implemented chat. We are currently implementing bulk update in SCIL, and subscription. I will show you subscription. It's a very interesting thing. Here we have the new inbox, which then lives in, I don't have any to point with here, but all this stuff here is still old page builder, and the SCIL is then hosted in this one pane card. The bulk update, there we open this dialog from the selection task view, and the dialog is SCIL. Everything else is the page builder stuff. So we can, and they work very nice together. And the subscription thing, that's very nice. This button is SCIL. The rest here is the old page builder framework. So why make a sliding button twice, right? So we used the one we had in SCIL. So you may ask yourself, is it time for change? You know, I'm a huge Liverpool fan, and this on Sunday, this Lovren, we need a change.
Change team. Wow.
No. But even though SCIL now is a part of sales and service, there's no need to rush. The page builder, if you have a lot of customization using the page builder framework, it's still going to be around for a long time. Page builder is still the main framework, and it's the page builder that hosts SCIL and not the other way around. So most of the panels, cards, etc. will be still page builder framework for a long time. Like I said, only the new stuff is going to be made in SCIL. And we have a little way to go to kind of document and package this stuff. It's very early days, but we are working on it. No, we will be working on it. That's right. Okay. Now the parts. There is a lot of parts. I tried to count all the parts. I found 19 different things in that that is interesting in SCIL. So I'm gonna go through the basics and I'm gonna show a little bit, explain a little bit about everything. So we have this factory mechanism. When we create the UI, it's described through a recipe, and therefore we need this factory mechanism to instantiate all the parts of a UI. So we have this global factory that has makes it easy to create the instances, and it makes it fairly easy to add new types, new classes, and replace if you want to make some component better than ours, you can exchange it. We don't have discovery, so you have to kind of register your class into the factory in order for the factory to know about it. So that's how the factory works, and then we have the router, which is responsible for executing the recipe. That's the access point of where you want to run your recipe. So you can either send in a recipe name, and then it will look up and check if it has a recipe with that name in its collection, or you can send in the actual recipe as a JSON into the router, and it initializes and creates the context, which I'm going to explain later what the context is, and then it also has the task of creating and retrieving running workers, which also is a concept I'm going to explain later. So this is this is typing from the router. So you can see we have the execute recipe. There you give in the name of the recipe, you give in the placeholder, the DOM ID of where you want this recipe to render. And after it's done, you have this callback function, then you can do magic stuff once it's initialized. So the router takes this recipe. The recipe is a description of how the context is set up. So all the parts of SCIL is set up from recipes, like it's a hierarchy, and every part in that hierarchy will get their part of the recipe to instantiate themselves. It's very similar to the page configuration, for those who are known about that and know that. It's of course not XML this time, it's JSON, which is a huge leap forward. But it's very easy to code when you have the right typings in the code, and you get IntelliSense and stuff. So you don't have to kind of wonder how the syntax is and how this is supposed to be. So it's it's much better than the page builder XML, which is a nightmare to work with. It's still gonna get fairly complex and fast. This is a very little example of a recipe. So every recipe has an ID, it has a controller, and it has a view. So in the controller you say which type of controller is this, and in the view we say which type of component is this view. And in this case, this is a flow component which has children, which has a label, which bind to the data message. So you can see a UI context is a variation of a context. It's a logical UI part. It's a part of what you can see in the UI. And every context, UI context, contains a controller, a view, and it has a state. The state is where the data lives. And This is the three things that a UI context contains of. So it's a logical UI part. It's what you see in the card, like this is the inbox, for instance. So it's a self-contained, isolated unit that only cares about itself and retrieves all the data it needs and is self-contained. So, like I said, controller, state, and an optional view. The UI context has the view. There are other contexts that doesn't have the view. The view is the one that holds the actual UI components, which is what you see on the screen. So context can have child context. You can have context within context. For instance, a dialogue is just a child context. It has own a separate context. And one page, there's no limit to how many contexts there can be on one page, basically. So the typical ones we have for now is like a page, like inbox you saw, like dialogues. We have something called callouts, which is like a pop-up with functionality. And we have workers, which is more like a background worker, background context that like lives in the background, have no UI, but it works in the background. And we have something called a ContextContainer that I will explain a little later. So this is a summary of what context is. It creates a controller and a view based on the given recipe. It holds a state, which is the data, and it kind of is the glue between the parts. So the context is the one that enables you to get data, set data, and gives you the possibility to listen to that data changes. So there we have the listen to, which is basically a data binding. When you register that you want to listen to this and this, data changes. And it also is the hub for commands. You have the concept of sending commands between components and controllers and context, and that is done through the context. Listen to is a data binding part. When a component gonna render the data, it typically listen to the data. It adds an event to listen to the data. So here's an example of the first line there is what typically is in the component. It says, I want to listen to, and then it's got the path, person, entity, first name, and whenever that changes, I want to do stuff. So whenever somebody from somewhere sets the person, entity, first name, do stuff will be called all the time. So this is used by components to get their data and change their data whenever the data is changing. And also it's used a lot in controllers that listens to changes in some data and do business rules, or it does calculations based on the change happening in the data. The data lives in what we call a state. It's just a simple class that stores the data. It typically stores in sales. We kind of retrieve the carrier from the net server and we put it in the state, and then the components bind against that. But we can have several carriers. It can have the form of whatever. we are accessing that state through these paths, so we can dot ourselves into whatever structure we like. This state, we also have a caching mechanism that we can put away the state and retrieve it, so we don't have to go down to the server all the time. So, the controllers. The controllers are more like, if you can compare it to something in the page builder, that would be the data handler. The controller is the one that kind of retrieves the data from net server through the data manager and puts it in the state. When you're starting a context or starting a page, it typically will, on initialize, load all it needs to be to load and put it in the state. So it also have the task of verifying the data from the state. So every time some component changes the data from and put it into the state, it has the role of validating the data and potentially stop a save or whatever and notify the user. Also, it usually put your code for what's going to happen when you save, where you're going to go next, and stuff like that. So the controller never ever updates the component's value directly. It only works on the state, and whoever listens to changes in the state will then get notified through that. So the controller has no knowledge of the components at all. So it just manipulates the states, and the components will get notified if they are bound to that state. The view is what holds what you see, basically. It's the div where you build the user interface. In service, it's normally equals as a screen. In sales, it's more like a view or a card or a dialogue. So that is the view. That's the visual part of the context. So in a view, you have the component. The component is the smallest visual part in SCIL. That's what you see. That's typically the inbox, the drop down, not the inbox, the input text, the drop down, the checkbox and stuff like that. So all components are derived from a base class that holds a lot of logic. So each implementation of a component is not necessarily very large, but it has you implement the render and the data binding and stuff like that. You also can, of course, have more complex components, but we try to minimize the functionality of each component, so it's easier to put them together and make them work together. We have components that is mainly layout containers that has the task of putting things together. Like vertical splits and grids and flow and flex and whatever. Unlike the page builder, we don't have any fixed hierarchy, so you can have containers in containers in containers in containers forever, if you like. So, yeah. So, kind of to recap the stuff. There's a flow of how things are going when you execute from the router, execute a recipe. Has components and it will make a big three of components. Yep. Context start. After that, context start is called, and then the controller then will populate the state with everything it needs, and it will call bind on the view. That means all the components will then be bound to that state, and then render will be called, and the magic will happen, and everything is rendered. That's how it works. And we end up with something like this. You have the context, you have the controller, the state, the view, and then a component, and then of course you have other stuff added to the component, which is validation behavior and other stuff, I will come back to. And component change flow. Before I take a tiny little demo, I will just explain the component change flow. When you have this rendered and in an input text you change something, the component will change, on change, it will set data value. That will use the data path it was set up with to set the value down to the state through the controller. The controller will then update the state and we will call data change. That means it will notify everybody that is listening that now this has changed, and it will also call is valid on the view, and that will recursively check every component and ask, are you valid or not? And then if somebody is not valid, you will get an invalid form event happening, and then you can show a message or something. So that's how that works. Now I thought I was going to demonstrate very, very simple. Can you see? How do you get higher the control? Wrong. Like that. Yeah. So this is an example of a standalone SCIL application. So we included the SCIL JS, the SCIL CSS, and some other requirements. jQuery we require. The high charts and moment are only required because I'm running the SCIL CRM package here. So basically on this code here, down here, we need to do the bootstrap in order to kickstart the SCIL, which is then register all the thing the factory needs and some other stuff. This is because I don't have any resources. I bypass the resource system, and then I execute the recipe, and I put it in the body tag. And after it's finished, done and stuff, I'm gonna set the state I called carrier, and I put this object, my text, hombre. And the recipe is this one. Has an ID, it has a controller, it has a view with a label that says hola data. The data is then the path, carrier.mytext. I have a Mexican wife, so this is the, after 4 years, this is the level of Spanish I know. Hola hombre. So so let's see if we have slightly more advanced. I'm not going to steal Anders' thunder, but I'm going to show the next one, which explains the data binding stuff. Here it's the same thing. I just put a container type flow vertical, and it's children. I put in addition to the label, I put in an input text that binds to carrier my text, and it has the change event key up. Otherwise the same. And then I can do like this. So now I have Ombre there, and then you see it's live with the binding to the label. Yay. Okay. Other parts. We have other parts. So we have something called workers. Workers that are kind of a headless context that is mainly used for background tasks. We use them today for when you log into the new inbox. We are starting a worker called inbox worker that in the background will every now and then go and check if you have new mail. And that kind of you just start it and it lives in the background and it resides there until you move away from the page. We have these other workers called notification worker, which is the notification system that we can show browser notifications or our own type of notifications that is always available. So in your code, in your controllers and stuff, you can call these workers and make them display stuff. So they kind of lives in the background. Also, the superstate worker is the glue between the old page builder and SCIL, which then keeps current changes and navigation in sync. So SCIL knows about currents through this superstate worker, because that superstate workers hook on to the page builder system and get all the current event changes and pass them on to SCIL. So you can, so that's why these two systems are able to work together so well. So this is kind of the glue between page builder and SCIL. So a worker context is very similar. It's basically the same as a UI context, except it doesn't have a view. So, so okay. A dialogue, as I said, is just a UI context. It's hosted in a pop-up window. So the dialogue is basically we just make a div, smash it on the screen, and put the context in there. So it's very easy, and it's very easy to use from outside SCIL. I have an example of here, the bulk update. This is how we use it from the selection card. We use the dialog manager open, and we don't pass in any context. That's the null. We don't have any context. That doesn't matter. We just send in this is the ID, this is the recipe name of the dialog, and here's the caption. And then we have the first function is when the dialog is opening, and it is open. We want to set some context to that dialog. So we send in from the page builder old, we send in the selection ID and the row count to the state of that dialog. And then there are things in that bulk update dialog controller that lives in there that listens to these selection ID and row count and populates the rest of the dialog based on that. So once it's finished rendering and you've done what you are supposed to do, you can close the dialog, and then this function will be called. And then you have access to the context. You can just go and get all the data you want from the context and use it in the page builder framework if you want. So very easy. This is like the connection point for between page builder and SCIL. We have something called Callout. That is more like, it's similar to dialog, but it's slightly simpler. It's like just a pop-up with no OK cancel buttons. It's like the super menu, for instance. Super menu is the thing, is the advanced MDO control, which you can search and you get preview and stuff like that. That's a callout. A callout can also be just a recipe part, and that's interesting. If we used in the inbox, we have this button down here called filter, and we wanted to show something to filter the list, and this is a recipe part, and that means that it will be instantiated in the same context as the one it was opened from. That means you have you don't need a separate context, but you can use the same context, and that means you can dynamically add recipes to a context and rebind these components through the existing state on that context, and that can be very powerful. So you don't have to make it will be a little overkill to have our own controller and whole state just to show these 5 checkboxes. So, but sometimes you need parts in your UI that should be very dynamic, but is also fairly complex. So we have made something called ContextContainer, which is just a component. It's a UI component, but instead of rendering itself, it just creates a placeholder basically, and it creates and hosts this new context inside. And what's powerful about that it's actually, you can bind the recipe name. So based on something happening in the parent context, you can change the recipe of the context container. And that's what we used in Inbox. So we have an example here of the context container. I have a recipe name with the equals detail recipe. The equal means that it's data bound. So that's the same as listen to. So instead of that being the name, it's pointing to the details recipe in the state. So, and then we have data connections that can transfer data from the current context to the context that lives in the context container. So we can pass state. And that is what we do on this right side here. So when you click on a mail, you get the details. If you click on 2 mails, you get a different recipe here with a multiple selection recipe where you can do other stuff. So that's how we change the UI, just by changing the recipe, the details recipe value will then change to the correct recipe, and it will re-render and rebind. And it's very fast and very efficient. I like it. Yeah. Okay. Validations. We have validations that we can hook on to the component. So we can have as many validations as we want. When a view asks if the component is valid, the validation will be evaluated and return no or yes. So whenever that happens, whenever components is changed and the state is updated, this is executed all the time. So you add the validation to the component by just adding for instance, a mandatory validation to the input text. And you can have an array of those if you need more than one. Yep. And then we have behaviors. Behaviors are also something you can attach to the component, and it's mainly used for enabling or disabling, hiding or showing a component based on rules, some rules. And it's fairly similar to the filter functionality in Page Builder, which then calculates based on some rules. It will remove or add XML, page config XML. And this does it runtime much faster. The typical behaviors we have is hide behavior, disable behaviors, something called spinner behavior, which is a little spinner. If something true, it will spin something in the DOM element of where you of the component. And you have add class behavior, like you can add CSS classes based on rules. Example, we use it, the 13, the bubble there is only shown if there are any unread mail. And that is done like this. We add the behavior of type hide behavior, we have a condition, and we bind it to show count unread mail. And if that false, it will hide the blue count. So, as you saw, there was we have this condition thing that we used in behaviors. It's a separate class that can be used other places than behaviors. It's not belonging to behavior, but behavior use it, and it enables live evaluation of conditions. It enables you to say this data value should be equal or not empty or empty to this value and stuff like that. And for instance, we use it on the inbox dialog when we are disabling the send and send archive buttons. We have a condition, or condition actually, that we added. We have added a disable behavior with a condition or true, and we have then two conditions. One is invalid form. If that's true, then we're going to disable it. Or if the account status is value 3, which means your mail account is failing or failed, then we are disabling the buttons. So that's and we have a lot of operators on the condition that enables you to do very good, powerful stuff. And I thought maybe I could show a little more. Not much. We have that. Same little thing. Only thing I've done is adding this validation here. So that's adding a simple mandatory validation, and then you get it works nice when you do this, but when you do that, it will give you a red style. Also, when it comes to behaviors, I have a little thing here called a little thing here. On the, I added a new label, and I added a caption, please hide me, and it binds to the carrier. Really doesn't matter. The behavior here is the hide behavior. I want to fade it away if the carrier my text equals get out. That's the demo. It's a very advanced demo. So then we see you have the label, please hide me. And then if I then write get out, it goes away. Ooh, and then it comes back. Ooh, magic. Ooh. Yes. Condition. Yep, that was behaviors. We have something called transformers that is used to translate data for a component. Sometimes you get the data in the wrong format, basically, different from what you want to display it. Like what you get from the server is not what you want to display. So then we have added some transformers, and we usually use it in date time and time spans and stuff like that. That is then transforming the data to the component and back. I'm not sure. Maybe 7 knows. So what you do is you have your component, you bind to the data, and you add a transformer, and you said, I want date time transformer, and I want the date format to be long, and then you get a long date. So you have a different set of transformers and that you can transform, and it's very easy peasy. Commands. Oops, low on time. We have commands. Commands is used to communicate between the different parts in SCIL. The way it works is that you can register to listen to a command. Then I want to listen to these commands, and then somebody will send a command, and everybody who listens get notified with this command. And we use that kind of just sending off commands, and whoever wants to listen to that command, that they can act and do whatever they want. So it's kind of a loose communication between the parts. So where we mainly use it is we use it all the time, like sending commands to the controller. A button you can set up to send a command, and in the controller you have added a register, command listener, button clicked, and then whenever that button is clicked, the code you have registered there will fire. Also, what we use it for, we use it a lot in workers. For when the inbox worker is in the background going and checking for new mail, sometimes you will get mail, and then it says, oh, I got mail, and then it just sends a command out, new mail, and whoever listens to that will then react. And if you are on the inbox page, the context, the controller there will most likely have registered a command listener that says new mail. So then it will instantly reload the list and show the new mail. But if the inbox page is not there, well, nobody will listen and nothing would happen. But the inbox worker will keep sending these commands, and maybe somebody's listening and maybe not. And yeah, you can send messages across contexts, because then the inbox worker context can send messages out, and you can register to explicit I want to listen to inbox worker new mail command. So then you can send across contexts.
But it's not a queue. You can't.
Oh, it's fire forget. So this is how it works when you, for instance, if you want to open a callout, this is a command that is registered in the controller base. So every controller has this ability to react on that command. And what it does is like you can send the command. You can typically put this in on a button. You can say send command open callout. In that you can say position, the recipe, and what to show, and you send in where to hook that callout, where it's attach that callout to this DOM element. So this is a way to send a command. Then this controller base, which has this code, will then act on that command and actually do the callout. And this is an example of commands across context. The notification worker, for instance, has this, they can show notifications. So what you do is you send a command with the notification worker dot show notification, and then the notification worker will act on that set of data it will get with the settings. We have managers. We're running out of time. 2 minutes. We have a data manager that is responsible for fetching and caching data. So when a controller asks, give me this data, the data manager will then decide, I don't have this data, I will go to the server, or I have this data, you will get this. And then the controller will should never get data for itself. It should always go through the data manager. The data manager also will provide data for various components is supposed to be there, like drop-downs and stuff like that. You don't have to go through the controller to get like the drop-down list always, so you can go to the data manager. So the data manager also has the ability to store session data that it lives during the session, and also we have enabled the local storage, which then data that will live over sessions. So you can store local in the browser. For instance, we store the dialog size and dimensions and stuff in the local storage. Also, we have an SO Data Manager version, which is a wrapper around the Data Manager, which then extends the functionality to be more SuperOffice specific. It knows about our web API, our preferences, the IX methods and the page builder system and archives and lists and stuff. So it's very SO specific operations that only lives in the SCIL CRM package. We have the dialog manager, which opens the dialog, stores the size and position and restore it, and adds the model behavior if needed. We have a resource manager. I'm just flipping through here now. We exported a lot of resource modules from our system out to SCIL, so we have access to many resources in the browser. You should be able to add your own, of course, but we then can get translated text just like this. And we have also inline resource parsing, and this is a little work in progress. The last one, periodic kicker. We have this thing that can kick off a set of code every now and the period you decide. This is useful for, this is again used in the inbox worker. It's every 2 minutes, every 5 minutes, it's check for new mail. It will kick off this code. And what's nice about using this one is that it lives in a context. So if you make a little dialogue with this kicker that keeps going, once this dialogue is closed and the context is destroyed, we take care of taking away this periodic kicker for you. So we kind of keep track of the kickers. So it doesn't like makes a lot of kickers that never ends. Yeah, that's it. And after now, Anders will show you a lot of nice examples and more detailed how you can use SCIL. So now you know the theory. Now you can get to the next session to know how to make stuff. Questions? We don't have time for questions, so I will be sitting down there when Anders is having his session. We can have questions then.